Welcome to Study Loop.
So since the belt does not slip, a point on the rim of the wheel C has the same tangential acceleration as the point on the rim of the wheel A. So we can say that the tangential acceleration for A equals the tangential acceleration for C. Therefore, alpha sub A times radius sub A would equal alpha sub C times radius sub C. We can then say that alpha, the angular acceleration of wheel C, would be equal to the angular acceleration of wheel A times the radius of wheel A divided by the radius of wheel C. This is giving us 10 centimeters over 25 centimeters multiplied by 1.6 radians per second squared. And this is giving us 0.64 radians per second squared. At this point, we can say that with the angular speed of c given by the equation angular velocity of c equaling the angular acceleration of c times time, we can solve for the time for it to reach an angular speed or angular velocity of 100 revolutions per minute. So we can say omega final is simply going to be equal to 100, or we can rather just say omega final c fine, or omega, the angular velocity final of wheel C would be equal to 100 revolutions per minute. And then we're going to convert, so 2 pi radians for every 1 revolution multiplied by 1 minute for every 60 seconds. This is giving us approximately 10.5 radians per second. And then the time starting from rest would be equal to t equaling omega final c divided by the angular acceleration of c. So again, 10.5 radians per second divided by the angular acceleration of c, which we found to be 0.64 radians per second squared. This is giving us approximately 16 seconds. So this would be our final answer. That is the end of the solution. Thank you for watching.